You don't have a big enough piece of graph paper to find negative 200. You're interested in positive values of x. Let me give you an example of where the y-intercept might have no meaning and not even be on your graph paper. Let's say we were looking at, the winning time in the women's 100-meter dash in the Olympics. And we went back to how far back the Olympics went back where the women ran 100 meters. And we took the winning time and plotted. The year was the x, the y was the winning time. And we looked at the points and said, well, let's try to draw a line. We drew a line. What's the equation of that line? Well, where is the y-intercept? Well, the y-intercept would be the time, the winning time, in the year 0. And of course, we could argue about if there was a year 0. But still, do you want to go back almost 2,000 years and use that number? I don't think so. So in many cases, the y-intercept would be meaningless. And again, the x-intercept in that very similar case. The x-intercept would be the x value when y is 0. It would be the year, the x, when a woman in the Olympics ran 100 meters in 0 seconds. I don't think that's going to happen. I mean, I think they're going faster and faster, but I don't think we're ever going to see a time when some human being will be able to run 100 meters in no time flat. So, what do we do if the x or y intercepts are unavailable or meaningless or won't fit on the graph paper? And that's where the last method comes in, and that's called the point-slope method. And the point-slope method, let me give you an example. Let's go over here to the easel. It might be easier to look at here. And let's take a look at the point-slope method. Let me get the exact equation. If you don't mind, I'm going to carry this over here so I don't look silly going back and forth. We're going to erase that. That was no good. Y minus 3 equals 4 times x minus 2. Now, there's an example of something in what's called the point-slope method. You may have seen this before. The general example is y minus y1 equals m times x minus x1. What that means is not important as yet. We'll develop it. But what you have here is an equation which can be put in slope-intercept form. Let's put it in slope-intercept form just to see what it means. Let's see. We got y minus 3. We're going to multiply through by 4. And we'll bring the minus 3 over by adding it to both sides, and we get y equals 4x minus 5. Slope is 4. Y-intercept is negative 5. But let's assume I was graphing this and didn't have any negative numbers on my axis. I was graphing it, like that, and where x and y are both positive. I couldn't find negative 5. Negative 5 was off my paper underneath here someplace. That wouldn't be very good. So, I want to take another look at what this means. Let's add 3 to both sides. Y equals, leaving the parentheses, 4 times x minus 2 plus 3. We know when x is 0, y is negative 5. We don't care about that. We care about what happens when x is 2. Why did I choose 2? Because look in here. What happens when x is 2? When x is 2, 2 minus 2 is 0. And 4 times 0, 1,000,000 times 0, I don't care what the slope is times 0, it's going to be 0. And therefore, when x is 2, y is 3. So what it means is that when you are given the point-slope method, you have the slope, you have a point. The point is 3, 2. Notice it's the opposite signs, because it's actually what number subtract 3 will give me 0. 3. What number subtract 2 will give me 0. 2. So x is 2, y is 3. Now to graph this line, we go over to 2, 3, wherever that might be, let's say over here, and we use the slope. Remember, this slope here, it doesn't change. The slope is 4. Over 1, up 4, over 1, up 4, and draw your line. And you'll notice that, of course, the y-intercept will be negative, but it's not on our paper. And for a lot of people, the 0.23 might be more meaningful. Now, one little problem. There's always a little problem. What happens if, when you got it in this form, you had y plus 3 equals negative 2 times x minus 1? Now, what would that look like? Well, let's think about it. You could rearrange it if you like, but remember we said, hey, the point is the x value that makes this in the parentheses 0. 1. Always the opposite. The y value is what makes that 0. Well, what plus 3 is 0? Negative 3. Again, the opposite sign. But if you don't remember that, just remember what makes it 0. Okay. What's the slope? So we find our point, 1, negative 3. X is 1, y, someplace down here. Our slope was negative 2, over 1, down 2, over 1. Line it up, draw your line. Of course, do it a little more neatly than I did, using a straight edge. I'm just demonstrating what to do. Obviously, we want it correct and precise. Another example. What if we had y minus 4 equals 1/2 times x plus 8? We want a point and a slope. A point to start with and a slope to go over and up or over and down. What's the point? No, that's not. What is the point? The point of this, of course, is to find the point. Can you find the point? The point, let's say, the x is what makes this 0, or the opposite side, which would be negative 8. And again, negative 8 plus 8 makes this 0. The y value would be what makes this 0, or the opposite sign, positive 4. There's my point, and what's my slope? My slope would be right out front of the parentheses. My slope is 1/2. And let's do this in blue just for the fun of it. And let's see. Negative 8, 4 might be over here someplace. There's my point. My slope is 1/2. Remember, that means 1 over 2. I go over 2 and up 1, over 2 and up 1. Draw my line. So once you get used to this, this is a very, very powerful tool, especially if your graph paper doesn't have negative values, you can't find the y-intercept, or the y-intercept is a huge number that you couldn't fit on your graph paper. So let's review what we've done in this lesson. We've looked at 4 ways to graph a line given an equation. The first method was plotting points. We got the equation in y equals mx plus b form, picked some various x's. I chose 2 x's that were negative, an x that was 0, 2 that were positive. You could choose any ones you wanted. Plot those points. Is 5 a magic number? No. But I figure 5 points, if I'm going to get one wrong, it'll be very obvious. The points line up, draw the line. The next method was using the x and y intercepts. Again, when x is 0, we get the y-intercept. When y is 0, we get the x-intercept. We plot those 2 points and connect them with a line. Remember the warning. You only have 2 points. If you misplot or misfigure one of those points, your line is wrong. Okay? And remember, we can use other methods to check our method. For example, we could use the next method to check the intercept method. The next method was the slope-intercept method. This is where we got the equation in y equals mx plus b form. We found the point that was the y-intercept 0b, plotted that point, and then used the slope. If the slope was a positive, let's say like 6, a positive whole number, over 1, up 6. If the slope was a negative number, negative 4, over 1, down 4. Of course, if the slope was fractional, let's say like 3/4, we say that 3 over 4, we go over 4 and up 3. The slope was a negative fraction. Let's see, negative fraction, negative 2/5. We'd go, say, negative 2 over 5. We go over 5 and down 2. We do this a number of times. So, for example, if the slope was Negative 3, we go over 1, down 3, over 1, down 3. Keep doing it until we ran out of time or space or we got bored. The points should all line up. Draw the line. But again, we always started at the y-intercept. The difference with the point slope method, was we started at a point. And again, if you forgot how to get the point, go back and look at the tape where we did those two problems. Find the point, then given the slope, starting at that point, go over 1 and up 3 if the slope is 3, or over 2 and down 4 if the slope was negative 4 halves. Whatever you wanted to do, however you want to do this is irrelevant. You have 4 methods. They all work. Each one can be used to check the others. You need to be able to find one method that works for you. In doing this unit in your Algebra 2 class, the teacher may expect you to use any of these methods and may specify, use this method or that method. But in general, for the future, I'd say find one that works for you and use that when you have free choice, and use it as a check when you must use one of the other methods. Again, the graph of a line is very important. In fact, it's so important we're going to use it in our next lesson, which is Lesson 9. And Lesson 9 will be all about graphing linear inequalities, whatever that means.